So before we continue any further in our project, we should now think a little bit about our project architecture. Now, there are some quite advanced architecture patterns in JavaScript, and we will actually talk a little bit about this by the end of the course. But in this small project, we will simply use object-oriented programming with classes, just like we learned in the last section. And so this way, you can then use these concepts here in a real project. And remember that the architecture is all about giving the project a structure. And so in that structure, we can then develop the functionality. And so in this project, I decided that the main structure will come from classes and objects. All right, so let's now dig a little bit deeper into this architecture that we're going to use. So to start, one of the most important aspects of any architecture is to decide where and how to store the data. Because data is probably the most fundamental part of any application. Because without data, it doesn't even make sense to have an application in the first place, right? What would the application be about if not about some sort of data? Now, in this case, the data that we need to store and to manage comes directly from the user stories. So right in the first user story, we can already see that we will somehow need to store the location, distance, time, pace, and steps per minute. And to fit the second user story, we will have to implement basically the same data. So again, location, distance, time, and speed, but then also the elevation gain instead of the steps per minute. And so we will design our classes so that they can create objects that will hold this kind of data. And I believe that this is the best way of designing the classes to really fit our user stories. So you see that we are going to have a big parent class which will be called workout. And so this one is going to hold the distance, duration in coordinates. And then we will have a more specific class for the running, which will hold the cadence and the pace. All right. And the reason why the classes are designed like this is because the distance, duration, and coordinates are common to both of the types of activities, so both to running and to cycling, and so therefore they are in the parent class. All right. And the same will also be true for some methods. And so we will see that once we implement it. And then for each type of activities, as you see, we have one child class, so that each child class can hold the data and methods that are specific to that type of activity. So I hope that makes sense. And this is the whole reason why inheritance basically actually exists, so that we can have more specific classes that can inherit behavior and common properties that are common to all the child classes. So the cadence and pace are specific for running, and then the elevation gain and speed are specific to the cycling. Okay? But once again, the cycling also has distance, duration, and coordinates, and so that's why they are there in the parent class, so in the workout class. Then here in this diagram, you also see that we have some other properties like the ID and date, but we will see why once we start implementing the code. And yeah, that's actually it for the data. So this kind of diagram is something that you will commonly see when working in object-oriented programming. So usually each class is represented by a box like this, where in the top part you're going to have the properties and in the bottom part the methods. And of course each class here will have more than just the constructor method. And so that's why I have these 3 dots there. All right. So for now, that's all we need to know about the architecture of our data. But now about the rest of the architecture, it's going to be more about structuring the code that we already have from the previous lectures. And the events that we already have are the loading of the page, then receiving a position from the geolocation API. So this one isn't an event in the traditional sense, so we're not handling it with add event listener, but we can still classify it as an event. Then we have the click on the map. We have changing the input from cycling to running, or from running to cycling, remember? And then we also have the event of submitting a form. And so all we have to do now is to create different functions that will handle these different events. And in fact, what we are going to do is to create a big class called app that will basically hold all of these functions as methods. So from a quick look at this application class diagram, we can immediately see that loading the page will of course trigger the constructor of the object that we're going to create through this class. Okay? And so then right at the beginning, we want to get the current position of the user using the geolocation API. And so that's why there is that arrow pointing from constructor to get position. Then as we receive that position, we want to load the map based on that position. And so therefore, we're going to have a method called loadMap. Then as we click on the map, we want a method called showForm. Then as we change the input, we want a method called toggleElevationField. And then, and probably the most important one, is the event of submitting the form. And this new workout method will basically be the heart of this entire class, because this is the one that will create new running objects or new cycling objects. And of course, these objects will be built based on the data that's coming in from the form. And as the user keeps adding running or cycling workouts, a new object will be created for each of the workouts, and each of them will then be stored in a workouts array, which will basically hold all of these objects. All right, so this is going to be an important class property that all methods of the class will then be able to use to work with the workouts. And so with this structure here, we have everything that is related to building the application itself organized into one neat block of data and functionality. And actually, having a class that contains all the data and methods about the application like we have here is a pretty common thing that you will see in simple JavaScript applications like this one. Now, if the application was a bit more complex, then we could divide this architecture even further and create one class that would only be concerned with the user interface and one class for the so-called business logic. So basically the logic that works only with the underlying data. But in this case, we can just keep it simple like this. And so, as I mentioned before, this architecture will then allow us to have everything that is about the application in one nice self-contained block. And besides the application itself, we then also have these classes that are only concerned about the data. And so therefore, application and data will be nicely separated in a very logical way, I believe. Now, what's also great about this is that we will be able to protect all of these methods so that they are nicely encapsulated and not accessible from everywhere else in the code. So that's the reason why you see these underscores on all of the method names, right? So that is, again, the convention that we can use to protect method names from being changed and used from the outside. And so this will make the code a lot easier to work with because we will know for sure that no place else in the code is working with the data and calling any of the methods here. And trust me, with experience, you will really start to appreciate these kinds of things. All right. But anyway, this is the initial approach for our architecture that we're now going to implement. And of course, based on the code that we already have. We will keep adding more methods and properties as we go, but this is already an excellent starting point. So maybe take another minute or two to study this diagram, and then in the next video, we will refactor our code to fit this architecture.